Hi, everyone. So this is the strategic, what is it called? Strategic solving, because, there's always strategy and everything. This is about equations with variables on both sides. But before we talk about variables on both sides, both sides, we have to talk about what if they're just on one side? Do we know how to solve those, right? So here's our warm up, 1, 2, and 3. If you've done these before, and you're like comfortable with them, these are the answers you should have gotten. And if not, I would really highly recommend that you pause it right now. Don't look at the bottom, just look at these problems right here and see if you can solve them, right? That's the best way to do. And if you're like, Miss Lee, I don't even know, like that's not even a thing, right? Then what you're gonna do is you're gonna just, let's just work on them together. So learning targets for today. Use strategies to solve linear equations with variables on both sides of the equation. Equal sign, I mean. Solve linear equations with rational number coefficients. When there was rational number coefficients, it's basically like I think rational, like fractional, that has a fraction as a coefficient, like number 3. Right? How do we deal with those guys? And then combine like terms and use distributive property to solve linear equations. We did not actually technically get to that yet, but that's okay. So these are things that you should have learned in 8th grade or 7th grade or 6th grade. I don't remember exactly which grade it is, just one of those grades. And so if you're like, oh, I don't really remember, if you learned it before, your brain will find it somewhere in there. It sometimes just takes a little while to get it out. And you're like, oh yeah. And if not, don't worry, it's cool. If you're like, I fell asleep on that part, that's fine, no worries. So if you look at this, 2.5x plus 100 is equal to 600. Well, what could that be? What could x be? So remember, order of operations is when we simplify things. So thus far in your math career, you have just simplified things. We've not really solved for equations. Well, assuming that if you don't know this yet, right? If you did do this, then yes, you know. But so remember order of operations, a lot of people remember as PEMDAS. So parentheses first, and then we'll do the exponents, and then we'll do multiply, divide. It's together like that because they're together, but not really together, you know what I mean? And you go from left to right, and then add and subtract left to right. Okay, so whichever one, meaning whichever one's on the left-hand side, that's the one that you do first. So if subtraction comes first, like in the way you read, then you do that first. You don't just, like some people think that, oh, it's add is always first. Add is not always first. It's whichever's one on the left. The left one wins, okay? And so that's how it goes. So now if you're solving something though, we're basically doing the reverse. We're undoing the order of operations, okay? So we're undoing all that. So that, so we're going to get rid of the add and subtract first, and then the multiply divide kind of thing, right? It's going to be, it's loosely based on that. There are, some exceptions to that rules. And as you do more of these, because literally for the rest of your mathematical career, you will be solving for X. X is always something that we're trying to find. We always seem to lose it. I don't know why. You can never find it. So if you take a look at this, remember, so the first thing we did was subtract 100 on both sides, right? Because, what you do to one side. When I say side, I mean like to the left-hand side of the equal sign and the right-hand side of the equal sign. Like that's what I'm talking about. And so we have to be, since they're equal, you have to do the same thing on both sides so that it'll stay equal, right? If you're taking 100 away here and just leave it like that, what's going to happen? It's going to be like, oh, not balanced anymore. So you have to also take 100 from this side. So it's like, oh, it evens out. It's balanced now, right? Kind of like the thing that we did last week. And if you don't know what I'm talking about, don't worry about it. All right, so we subtract 100 on both sides. So now we get 600 minus 100, which is 500. And then this 2.5x, we didn't touch that yet, so we're bringing that down. If you notice, 100 minus 100, what is that? And this is why we did 100 minus 100, so that it just becomes what? 0, right? Because 2.5x plus 0 is what? 2.5x, and that's what we say cancel out, right? Because it cancels out. You can use the quotations if you want. So if you want to do one of these cross out thingies, you can do that if you want. You don't have to. And then if you notice right here, we have the 2.5x. So how do you get rid of this 2.5 for the x? We want just x. What is just x, right? Because we know whatever this x is, if we multiply 2.5 with it, it should give us this 500, right? And so the way we do this, we're going to undo whatever this operation is. And what is that operation when they're like next to each other? It means that they're what? Multiplying. Right? Yeah, that was weird. They're multiplying. So whenever they're next to each other, there's no operation in between them. It means it's multiplying, which means what is the opposite of multiplying? Dividing. You can just divide it. Okay, so that's what we divided out. Oops, wrong side. Divided out the 2.5. Okay, and then so we get, if you use your calculator, you can do that. Or if you just know how to do that in your head, that's great too. And then your answer would be 200. And if you want to do a little quick check, you know, well, 200 goes into 2.5 how many times? Or oh, erase that. 200 times 2.5 is what? Right, 500. And then add 100, that will give us a 600. So that this 200 is the only number that's going to satisfy this equation. There's no other number that will make this work. And it'll be equal to 600. No other number. If you could find another number, let me know. So same thing with number 2, doing the same thing. Now, how do you know whether to like add 4 to both sides or subtract 10 on both sides? Technically, you could do either one of them, but only one of them is going to give you a better, like closer to your answer of what X is, okay, to your search in finding out what X is, right? And so we want to get rid of the numbers that are on the side of X. So whatever side X is on, those are the numbers we want to get rid of, okay? So that's why here we added 4 on both sides, because since it's subtracting 4, what is the opposite of subtracting 4? We want to undo that. You got to add 4, right? So that's why we added 4 on both sides. So we got 10 plus 4 is equal to 14. And we're going to bring down this 2x. And what happens to this minus 4 plus 4? What is that? 0, which means it's just 2x plus 0, which is just 2x. And that's why we don't have the 0 there. Now, remember those two numbers are close together like that. What does that mean? Multiply, right? And so how do we get rid of a multiply by 2? Divide by 2, goes on the bottom. And the way we show divide by 2 is always with this fraction bar. We're no longer going to use this divide sign. Just get in the habit of that. A lot of more people, and it's a lot easier to write just like one line as opposed to line, dot, dot. Although, you know, honestly, I really feel like, now that I think about it, these 2 dots are actually like the fraction bar, and here are the numbers. Like this is the number on top and this is the number on the bottom, right? So the division sign is actually like a little mini fraction. Revolutionary. I just thought about that right now. What in the world? All right, so here we go. So here's our divide by 2 on both sides. And why 2? Why not 14? Because the whole point of this is get X by itself. Give me a second. I was trying to not record my sneeze. So, whew, hopefully I made that in time. I was like, I have to sneeze right now. Okay, and so that's what we're dividing by 2, is because we want to get the X by itself. So why divide by 2? Because think about it. 2 divided by 2 is what? 1. And what is, and notice it's not 0, because what's 1 times X? X. And so literally X is by itself, right? So there we go. So that's why we're dividing by 2. And again, we still call this cancel out because we no longer have to see those numbers anymore. All right, so if you want to do a little boop, you can. All right, so it's 14 divided by 2, which is just 7. So 7 is equal to X. If you want to rewrite that as X equals to 7, because for me, I like to have my X's on the side, on the left. That's how I like to do that. You can't, because remember, if they're the exact same thing, you can just whoop, Tweedledee and Tweedledum, doesn't matter, right? I'm just kidding. All right, so here we go, X is equal to 7. Again, if you were to put that back in there, 2 times 7 is 14, minus 4 is 10. If you're one of those people who just like to think about it, we're like, ooh, I control the system here. I can be like, okay, what number, if I multiply by 2 and subtract 4, will give me 10? And you'd be like, 7. And you'd be like, oh, and don't show any of this work. That is not helping yourself out. Because I will tell you, no other teacher is going to be like, oh yeah, that's great. Because what I want to know is not, can you figure out the number for X? Is, do you know how to undo this whole process? That's what I want to know. I want to see this process here, right? So please do it this way. If you learned it another way, please let me know so I don't like ding you on that. Okay, and so for this last question right here, number 3, again, we're going to get rid of the adding and subtracting first. Here we're adding 5. So opposite of that is subtracting 5. And then here, oh, this is what somebody had done in class, which I thought was cool. Ignore this little dot that doesn't actually belong there. And so this 1/4 X is here. And so what this person did was actually just multiply these guys, because remember, they're close together. What does that mean? It just means multiply, right? So 1 times X is X. And remember, any whole number is divided by 1, right? Over 1, right? If you want to like have fractions together. So 4 times 1 is just 4. So this is actually x over 4. And I really like this strategy. It's a great one. So then it just looks like none of the other ones that we did. But how do we get rid of a divide by 4? Right? What's opposite of dividing by 4? Multiply by 4. And so that's why we multiply by 4 on both sides. Okay. And then so these are gonna cancel out, right? Because 4 divided by 4 is 1, and 1 times x is x. And then here 25 times 4, which would be 100. I just want to say that there's a trick. It's not really a trick, but there's a way that you can get rid of these fractions, because I personally don't like to deal with fractions, because I don't like I do like fractions, but I don't like having to what is it called, do them when I'm trying to solve an equation, because you have to think about like common denominators and all that kind of stuff. You can, you can't, all that stuff, right? I don't like that. Integers are much easier to work with for me. So what I like to do is I like to just multiply by whatever my denominator is. So in this case, I want to get rid of this 4, because if this 4 was not there, we wouldn't have fractions and we'd be fine, right? So what I'm going to do is multiply by 4, right? So 4 times everything inside. That's why just everything. Okay, and then so if I go 4 times 1/4, that's just 1, right? Because 4 is just like how we did here. It's just 1, right? So it's just x. All we have left is x, or 1x if you want to say that. And 4 times this 5, right? Because we're multiplying everything by 4, so that would be 20. And 4 times the 30 is 120, right? Do you see how much easier this looks? It looks much easier, right? Like automatically right here, right now. So there we go. So what we're going to do here is now we just subtract 20 on both sides and we get x equal to 100. X is already by itself, so we don't have to multiply or divide anything. It's already just x. So x is equal to 100. So that is the other way. And this is how I like to teach my students, how to get rid of fractions in these ones. There were other people who solved this by changing this fraction into a decimal, which is okay for like 1/4, because it's a non-repeating decimal, right? It's just 0.25. So, and then just divide both sides by 0.25, which is fine. But if you have something like 1/3, where it's a repeating decimal, 0.33333333, you won't be able to get an exact answer, because you're having to round it, because it's technically a repeating decimal. So I would not use that approach when they're repeating decimals. Then what do? Do either what this person did here, where you multiply it so that it's just one fraction together, and then get rid of the fraction, which is by multiplying, or just get rid of the fraction from the very beginning. Either way, doesn't matter. Okay, so that's what I would do. Okie dokie. So we are now on to the next stuff. If you notice right here, these are all the properties that we were just using. Because did you know these all have names? It's a property of equality, right? This is how we stay equal, peoples, right? So it's the addition property of equality. So if you, so if you if A is equal to B, right? A is equal to B. Here's A, here's A, here's B. If A is equal to B, right? And then you add a C to both sides, it's still going to be the same thing, right? They're not the same thing. They're still going to be equal, because we're adding the exact same amount to both sides. Do you see what I'm saying? So if you have like Annie and Barry, and they have each, I don't know, $5, let's just say. And then I give them a C note, $100. So I gave each of them $100. Do they still have the same amount of money? Yeah, they have more money, but it's still the same amount. They both, Annie and Barry, have the same amount. You see what I'm saying? All right, so it's the same kind of thing. So now if I take the same Annie and Barry, they have the same amount of money, but I take, or they spend, I won't take, they spend the same amount of money, right? Minus C, minus C. Are they going to still have the same amount of money compared to, each other? Yeah. All right, so that's what we call the subtraction property of equality. I know, crazy, mind-blowing, right? Can you imagine what we do with multiplication property of equality? Probably going to multiply something, right? Yeah, so again, for multiplication, if you multiply both sides by C, the same number, right? You will result in the same number, right? So if A is equal to B and you multiply them both by C, they should still be equal, because if they're not equal, there's something wrong. You should like look around and pretend it like maybe it's a dream, because if they're not equal, this might be a dream. All right, now the division property of equality says what? If you divide both sides by the exact same number, it's going to be equal to each other. The only thing you can't do, if you see this little stipulation there, they're like, you can't divide by 0. You just don't. Friends don't let friends divide by 0. Okay, bad things happen when you divide by 0. If you ever wonder what could happen when you divide by 0, look up Y2K. There was a whole big thing about dividing by 0, and there was issues with that. They even made movies about that. I'm just saying. So yeah. So there's that. And we're going to move on down to here. And again, this packet is in the Canvas page if you don't have it with you. That's fine. So we looked at Teddy and Topher. They have both the same equation, but they kind of handled it a little bit differently, right? So Teddy decided, well, I want to get the X on the right-hand side. So he did. So he subtracted 5X on both sides and then proceeded to do, and once we did that, right? And now it looks exactly like our do now, right? Our warm up. And we have just X on only one side instead of both sides, right? And then you just solve it the way we normally would, like subtract 5. And then I'm trying to have these color coordinated here. So 3 minus 5 is -2, right? And then what do we do after that? Well, we got to get rid of the -3. So we divide by -3. And you get 2/3 equal to X. And see, Teddy's like me. He's like, I don't like this X being on the right-hand side. So he just flipped it, which is fine because they're both equal to each other. Same thing, right? So now Topher, Topher did a little bit different. He's like, or she, I don't know if Topher's a girl or boy, but Topher, I'll just call him they. Topher wants to get the X on the left, right? So subtract 2X on both sides, right? And you get 5X minus 2X, which is 3X. Now my X is on the left, which means what? Got to get rid of that 3 now, right? So subtract 3 on both sides and then divide by 3, right? And now you get X is equal to 2/3. Either way, you still get 2/3. So honestly, it does not matter. Do you want your X on the left or the right? Whatever way you want. For me, I would have maybe chosen to do Topher's way just because I don't have to deal with negatives. I try to avoid negatives like the plague. I'm just saying. So I would do Topher, and plus the X is on the left. So I would like that way, right? And so if you notice right here, I had asked, do you want to use Topher or Teddy's way? And somebody had said Teddy's way. So we're like, okay, wait, Teddy's way, did we do Teddy's way? Oh, we didn't, we did Topher's way. Oh, because we said we wanted to do Topher's way, that's right. All right, so we moved it to the left, which is fine, right? It was not my preference just because I would have liked to just subtract X on both sides so that we don't have to deal with negatives, right? But that's okay. And so we're going to subtract 5X on both sides. And we get -4X minus 6 is equal to 10, right? The things that we don't use, we just bring them down. We didn't use the -6, we brought that down. We didn't use the 10, so we bring that down. The 5X's cancel out, so they cancel out. We don't need it there anymore because it's just equal to 0, right? And then from here again, now we just have one variable on one side. So so opposite of subtracting 6, 6, right? So we got 10 plus 6 is equal to 16. And we have this -4X here on the left. Now we're multiplying -4 with X, right? What are they doing? Are they adding, subtracting, multiplying, or dividing? They're multiplying, right? They're next to each other like that. There is no operation in between them, right? Which means, what is the opposite of multiplying by -4? Dividing by -4, right? It's if you're dividing by +4, that's not the same number. It's a different number. You can do it, but you're going to be left with a negative there that you need to get rid of anyway. You're just adding more steps because you got to get rid of the negative now. Then what do you do, right? So we're just going to multiply by divide both sides by -4. Okay, and then so you get X is equal to -4. And I had said I would do B. So right now, if you have not done this already, press pause. Well, copy this down, then press pause, and then try to do it yourself. All right. So I'm going to assume that you did that. And so I noticed here, I could either subtract 2X on both sides or add 5X on both sides. And I'm like, I'm going to go with the add 5X on both sides because I don't have to deal with negatives then, right? So I'm going to just add 5x on both sides. So now do you have to get rid of the x's first? I personally like to, just because it gives me a direction. So once I have x's on one side, I know which numbers I need to get rid of, right? So that's what I would do. That's my recommendation for you. Do you have to? No, you don't have to. You could do it some other way if you want to. It doesn't matter. So let me just say right here. So once we have that, my negative 5x and 5x are going to cancel out, right? And all I'm going to have left is 2x plus 5x, which is 7x. Bring down my minus 7 because I did not use that yet. And also my 14. All right. So now, what are we going to do here? So I have two 7s here on the left, and I need to get rid of them. So I can get rid of them all at the same time. So what I'm going to do first, remember, get rid of the add and subtract first. The thing that's furthest away from the x. So I'm like, okay, a minus 7, the opposite of minus 7 is plus 7. I'm going to add 7 to both sides. Addition, property of equality. Right? And then so we have here 7x is equal to 21. All right. And then now you can think in your brain, well, 7 times what will give you 21? You're like 3, right? But we're going to just algebraically solve this out. So we know if we don't get 3, we're like busted, right? So what is the opposite of, remember when they're close together like that, what does it mean? It means it's multiplying. So multiplying by 7, opposite of multiplying by 7 is dividing by 7. So we're going to divide both sides by 7, just like that. So what do we get? X, I'm going to put right over here. X is equal to 3, which is, yeah, that makes sense. There we go. But and if you did, then if you want to try do minus 2x first, right? Instead of add 5x, see if you get the same answer. It's a good way to practice. I'm just going to do one more question here. Let me just see here. Let me do this one. So if you take a look at A, right? Just you know, to make things interesting. I'm going to, let's just try A. And I'm going to tell you how you can, remember what we said, we're going to get rid of these fractions by multiplying by a number. And notice that there are 2 different numbers here. There's a 4 and a 2. Well, what number does 4 and 2 both go into? Don't say 5, because that wouldn't make any sense. 4 and 2 don't go into 5. So like you can use, some people, maybe you said 8, and that's fine because 2 goes into 8 and 4 goes into 8, right? But you can get a smaller number. That's why they say the LCD, the least common denominator. Least common denominator, yeah. So that would be the 4, right? 4 goes into both of them. So what you can do is just multiply everything by 4. Probably should not have used a color that is so similar to the books. Okay, there we go, changed it. So we're going to multiply everything by 4. Okay, now you got to look really carefully because it's a little bit tricky here because we do have a parentheses inside another parentheses. Okay, so that gets a little, but it's fine. It's fine. So you have to treat this as one entity. When they're multiplying like that, they're one entity. Okay, so when we multiply this 4, that's just going to cancel out this 4 right here. We don't have to distribute to that stuff in the inside. We're not. It's just they're one thing. Okay, so it's 4 times is 1/4, which is just what? All we're going to have left is this x minus 5 because there's just a 1 on the outside at that point, right? Okay, if you did not get that, rewind it and watch it again. All right, and then we're going to multiply. I'm going to do the second with this color. So the 4 was now multiplied with this 4 right there. And that was this answer right here. And then this next color, this 4 is being multiplied with the 9. So this can be plus 36. Okay, so that's the plus 36. And then orange, and multiply that one. So it's equal to 4 times 1/2, right? Remember, if you want to think about it, 4 divided by 2, right? Which is just going to be 2, right? It doesn't cancel out, but it just becomes 2 at this point, 2x. Notice we don't distribute to the x because remember 2 and 1/2 and x are what? They're together, they're multiplying, right? So just like how we did with the parentheses, we don't do that, we don't distribute that separately. That's together. Okay, so we just do it that one time. Okay, so that's 2x. Got it? All right, if at any point of that you were confused, go back and watch that again. Okay, and let's see here. This is black. Okay, so from here, I'm just going to combine like terms because on the left-hand side, I noticed that I have two numbers that should be together that are not together. I'm like, we're going to simplify this guy out. And so it will x minus 5 plus 36 is going to be plus 31 is equal to 2x. And if you notice, I will use minuses and negatives kind of interchangeably, okay, because they're pretty much the same thing. In my mind, they're pretty much the same thing because this minus, I could just change this to a plus negative. It's the negative number, right? It's the same thing. All right. From here, I notice I have two x's on both sides, but I have only one number. What is that? So what I do here is, again, we want to get x's by its like together. So either you can subtract x on both sides or subtract 2x on both sides. What I'm going to do is, since I have the number on the left, I'm just going to move that x on over. So I'm going to just subtract x on both sides, just like that. So then I'm going to get 31 is equal to x, because 2x minus x is just 1x. And we know that if it's just an x, it's already a 1 in front. So it's just x. So x is equal to 31. Okie dokes. So that's how you would do that. All right. Hopefully this will help for you. Do the exit ticket and check your understanding. All right. I'll talk to you later. Bye.